It's super warm here too. It's super nice.
Yeah, very nice.
If we were in person, Taylor, I would ask to have class outside.
Yeah. No chalk. We don't have chalkboards outside, so I guess we could just all take our tablets now and go outside. Since we're experts at it. We just all be on the Awe app and go hang out.
Yeah.
Right.
Is UVM's a chalkboard place? I've never been inside one of the campus buildings besides the test room. So
yeah,
it's chalkboard.
It's a it's a mixture of both. Yeah. So, by the way, Jeremy was right. There is no class on Wednesday. You've got like spring break day. So on Wednesday.
And watch it be rainy and cold.
Yeah. It's supposed to be a steady day, but I think you guys should use that time however you want, of course. And then what else was I supposed to say? So some people wanted to go over the quiz problem in office hours. I'm going to do that tomorrow. And I think I had one more piece of administrative things. I don't remember. I'll post it in the chat if I remember. Okay, so we're going to start something new. We're going to talk about Grobner basis algorithms. So this is section 9.6.
Wait, Taylor, can I ask a question? Because it's been bothering me all morning. There is a female mathematician who comes up in algebra because we've named something after her, and I cannot figure. Do you know who it is? Do you know what I'm saying?
Emmy Noether?
Yes, thank you.
Yeah.
The name escaped me.
Yeah. I mean, she's super famous. Yeah, she's like.
That's what it was. It was from Noetherian because I couldn't spell it. And
Noetherian.
Yeah. But anyways, yes, thank you because it's been driving me nuts all day.
Yeah. By the way, this whole topic here stems from proving some things are Noetherian. So there's a good. So this is section 9.6 of Dummett and Foote, and they do a really great job. Right. So, but you'll see they motivate it really well with the Hilbert basis theorem. I'm going to try and motivate it by examples.
Are those dots over the O?
This is this thing here. That's a section symbol.
No. Over the name Grove.
Yeah, Grobner. Yeah, it's an umlaut. Or some people will write it Grobner, or if you're really lazy, you can do Grobner. But if you do this, just be aware that you're going to run into German people and they're going to get mad at you.
They're going to hate you.
They're going to hate you. They will hate you.
Okay.
I mean, it's like offensive. So you'll run into mathematicians, it's an international thing. They have different names that use different characters. And if you don't use their characters, they get mad, except for French people. So French people get less mad.
I would strongly recommend OE if you're not going to go for the umlaut, because just the O that's just incorrect. It just isn't right. So strong recommend.
Yeah. Okay. Or you can call them G bases. And then skirt the whole issue. Okay, so let's do some motivation here. Okay, so there's a famous example. Okay, so here's a motivation. Okay, so there's a curve that's called the rational normal curve, and there's a rule at Berkeley, right, in the Eisenbud seminar, that if you give a talk, this curve has to appear in the talk somewhere. It's like what they ask all their speakers to do. And so I'm going to show you this curve. Okay, so the rational normal curve. So consider the rational normal curve. The rational normal curve. Right. So this is the okay. So this is the image. Okay, so this is the image of the map C to C3 given by t maps to t squared t cubed. Okay, and so if you want to be slightly fancier, right? So this is also a map from A1 to A3, right? And so this is maybe, if you call this spec of C of t, and this is spec of C of x, y, z, right? Then, so this is like looking at the C points of this thing. So this is kind of the classical picture. But if you do this, then the map here, the map is induced by the ring homomorphism C of x, y, z maps to C of t, or sorry, the maps to C of t, right? Where x maps to t, y maps to t squared, and z maps to t. And so you should think of this as kind of like the pullback of the functions to this curve. So if you pull back x to C of t, you'll get t. If you pull back y, so pullback means you take a function on this space here, and then you compose it with, you do this map, and then you take the function out. And then if you do those two in combination, you'll get a function back on C. And so
Z go to t cubed?
t cubed, yeah, that's correct.
Can I ask kind of a quick side question? Is spec of CT, spec of the polynomials over C, is that bigger or smaller than C itself? Or maybe you can't even make a comment like
Yeah,
that.
so this is so yeah, that's a good question. They're kind of not really comparable. So yeah, so what is the comparison between the two, right? So A1, so there's two ways to do it.
I know the maximal ideal are
A1C of C, the C points, this is just C. Or the maximal ideals of spec of C of t. Right, so these are in bijection with C via, x minus a, y minus b. I'm sorry, x minus a only. X minus a maps to a. Right, so so this thing is strictly smaller.
smaller than spec of CT itself, right?
Yeah, than the spec of CT. Because
and then the more variables you add,
the only thing you're missing here is the zero ideal in this case. But for 2 dimensions, it's different. Yeah. So, but I mean, let's just think about this in terms of points, like old-fashioned points. Okay. So consider the image of the map. So the image of this map is called the rational normal curve. So the image is the rational normal curve. Okay, and so here are some questions. So one question is, okay, so so what equations are the equations of this curve? Okay, so so here are some examples, right? So clearly, there's some easy examples. So really, y minus so y minus x squared, right, is equal to 0. You could do z minus x cubed is equal to 0. So these are 2 equations that are satisfied by this. Or you could do z minus xy is equal to 0. Right. So these are some obvious equations satisfied by the rational normal curve. Agreed? So, you really have the second component here is the square of the first component. And the third component is the cube of the first component. And then if you multiply x and y, the x and y components, you get the third component. Okay? So are these all the equations, right? Okay, so here's a question, right? Is it the case that z minus xy is an element of y minus x squared z minus x cubed? Right? How would we show something like this?
I mean, is it like a linear or algebraic combination of those two, or?
Well,
Or you mean
what does this statement mean, right? So this statement means, right? This statement means here that I'm asking does there exist an A of xy, yz, and a B of xyz in C of xyz, such that z minus xy is equal to A of xyz, y minus x squared, plus B of xyz, z minus x cubed, right? So does this more complicated equation come from these lower equations here? Right, so that's the type of question we're asking. And I guess, you can make this arbitrarily complicated, right? So in this question here, I didn't really need to consider this rational normal curve. We could do this more generally, right? Right. If I look at a map from, you could look at a map from Cn to Cm, and it'd be given by x1 to xn maps to, and then you could just pick some polynomials. So it's kind of a super interesting question, right? Okay, so I have all these weird maps, right? And so like, what are the images of these maps? Are they, they're cut out by polynomial equations, right? Or the closures are. And we want to figure out what those equations are, right? Okay. So, all right. And so the way that we're going to do this, so there's other additional questions that we can answer using Grobner basis techniques, but these are some of the big ones. Let me just say some other questions we can answer. So okay, stop. Oh. Okay. All right. All right. Okay. So the way to answer, so what are the other questions we can answer? That's Christelle getting something from the freezer.
Hi, Christelle.
Hi, Christelle.
She's got.
Hello.
Okay. So how to determine if an ideal is prime. So this is all about polynomial rings over a field, by the way. An ideal is prime. So there's like an algorithm for this. How to determine if an ideal is radical is something else you can do with this technique. Okay, so so this is kind of this thing here. This problem here is sometimes called the ideal membership problem. And determining whether or not you can do this or how to do this is kind of interesting. Okay, and so to start with this stuff, we need to talk about term orders and polynomial long division.